Hey everybody. Um, my name is Joe. I'm the moderator for today. For this first session, we've got Vishek Petrus, who's going to be telling us about GIS. Same deal. Well, I'll give you the 10-minute warning, 5-minute warning, 1-minute warning, and then we'll have 5 minutes of Q&A at the end.
Thank you. Yeah, so tips and tricks for GIS 8.2. Yeah, my name is Václav Petraš. I go usually by Vašek. I work as a geospatial software engineer at the Center for Geospatial Analytics at NC State. And among other things, I also work as GIS developer. I'm part of the development team and the project steering committee. So first tip is pick your GIS version. The current version is 8.2 with latest update in January, but we also have a legacy version which we maintain. There is no reason for you to necessarily pick it up, but it's good to know that if you are for some reason stuck with an old version on an old computer or something like that, we are maintaining these old versions. And then there is also a preview version. Currently that's 8.3, and that version is built daily from the latest reviewed source code, and that's your way how to test the latest features in GIS. Next tip, explore both core and add-on tools. We have over 400 processing tools in the core GIS when you install it. No extensions, no additional installations. But you can also explore another 400 tools in the add-ons repository, and these tools are the more experimental tools or very field-specific, domain-specific tools which don't fit into the main repository. The community, developers and users are deciding which tool goes where. So this also can change with the time as the tool matures or becomes more important. Next tip, use data management panel. The new GIS interface since version 8 includes a new data management panel where you can manage all your data in GIS, imports, exports, all your GIS projects there. But also explore all the other panels, because I have noticed that sometimes people forget about specific panel here or there. There is a list of tools, there is also a console, there is a Python interface as well. Next tip, switch to single window interface. You can do it already in 8.2. We will be doing the switch in 8.3. The single window interface will be a default instead of the multi-window interface. That will still be there, available, and it's really good for like multiple screens and things like that. But as a default, we are going with single window, but you can do it right now. And if you have used GIS before and struggled with the startup screen, then just forget about it. There is no startup screen anymore. You just jump right into GIS. And if you have not used GIS before, the first time you start it, you will get tips how to proceed. So please do follow these tips, at least do read them, and this will guide you in setting up your GIS project. And with that, another tip is use map sets to organize your data. Map sets are sort of sub-projects, and we may actually rename them that way, and they are for grouping related data. The nice thing about the map sets is that when you are working with a specific map set, you can only modify data in that specific map set, so all your other data is protected when you are like rerunning your analysis and you are creating a raster called DEM. It will not overwrite raster DEM in your another map set. It will create a new one in your current map set. At the same time, when you are using one map set, you have still access to all other data in other map sets. So it works all nicely together. Another tip is to use Python to automate your workflows. If you are not using Python yet, consider using that. In GraphGIS, you can automate both the processing workflows, but also the visualization. And the API or the Python functions for that are constructed in the same way. So you don't have to necessarily learn something new just to display your data. Everything will be just seamless and the same. And with Python, consider also using Jupyter Notebooks. They are this mixed text of code, results, and images. And it sounds a little strange if you hear it for the first time, but actually it works really well. It's interface you are using in a browser. Everything works well thanks to HTML and other modern technologies. And it's really good for prototyping, reproducibility, or creating tutorials or explaining what you did to get the data you have. And the version 8.2 of GraphGIS has this grass.jupyter package, which makes the integration with Jupyter really seamless. Another tip is that you can generate web maps quickly, also with this Grass Jupyter interface. So you can get this interactive map for small or middle-sized data very quickly. It will be static map, but static in terms of there is no server needed, but what you get is interactive visualization. You can also create 3D visualizations with the Grass Jupyter API, and the interface is again similar to the other ones. And another tip is check the command line interface. My t-shirt is clearly old-time reference, but command line is cool again. So consider using that. What GraphGIS gives you is that for each tool, this is a dialog you get for each tool, and at the bottom of it, there is the command written, and there is a copy button to copy that command from the graphical user interface. And you can then paste it into a text file, paste it into an email, or paste it into a command line and run it. And that way, you can get started with these automated workflows much easier than, let's say, learning Python. Another tip, use smaller region extent for tests. In GraphGIS, we have this concept of computational region, which clearly specifies what is the extent and resolution of the raster calculation which you will do. And what you can do really easily is that you construct your workflow with a smaller region, a smaller extent, the same resolution as your final resolution will be, but the extent will be smaller. And you do your all workflow with that, and then you change your region, and then you redo your workflow with the larger extent. And that way you tested everything with smaller extent. It was very fast, and then you compute it on your big data. It will be still very fast in GraphGIS, but it will be even faster with the smaller region. Next tip, align your grids. With computational region, one thing which is often really good to do is to align the grid to something you want to work with, like another raster. So you see that these two grids are kind of misaligned, but there is a way how to align a grid of computational region to a specific raster. So it will actually match like your input raster or your NLCD dataset or something else which is the main grid you are using. You can also align it to multiples of a resolution. So you can have 10-meter resolution, but your grid cells will start at 12 meters, 22 meters, 32 meters. So with this align option, you can actually have your cells at 10 meters, 20 meters, 30 meters, something which is more what you expect. Then attach semantic labels to rasters. So if you are doing remote sensing, you can attach semantic labels either to individual bands of an image, and this will really create a seamless workflow for classifying multiple scenes, like multiple lensed scenes, or you can use these to further organize your time series and then just pick piece of the time series, like only the red band or only the sentinel to one band. If you are not using if you are not doing remote sensing, just don't worry about us. Then see the tool's performance parameters. There is now several tools which are parallelized. So check the documentation and check the user interface, where you will find a parameter to specify number of cores the tool should use. And also you will find there an option to increase the memory footprint the tool can get. And this will potentially significantly speed up the tool. If the tool is not parallelized, you can always run multiple tools in the background in GraphJS, no problem. Next step is to read the performance documentation for the tools. So some of these tools, which are now parallelized, have a performance section where you can read about how much you will gain with different memory and core options, and also what will be the disk usage. So this way, it ensures that you are not throwing additional cores on a specific tool without actually getting any significant gain. Usually, the biggest gain is like with 2 or 4 cores, and after that, you are getting a little bit of improvement, but not much. So you can actually run another tool in the background and get most of it. But if you have just all these cores, you can just throw them there, and it will work. Next tip, link data instead of importing. So the typical workflow would be you link or import the data to GraphJS, and then you do your processing, so you don't have to fiddle with the specific formats during your actual processing, and you can focus just on the processing. The advantage of linking is that it's much faster than importing, and it can be really super fast for like large rasters, and it's really nice for workflows where you have large data set, but you are actually just interested in a small portion or small selections of the data set. Next tip, don't limit yourself to desktop. We have, the typical workflow would be to run Graphs on like a GIS nice desktop workstation, but Graphs will run just fine in like a small virtual machine or Raspberry Pi or your old laptop. So you can use those. We are also running GraphJS in Docker in more cloud or reproducible settings on several institutions, including NC State. We are running GraphJS on HPC clusters. And then if you are thinking about cloud, check out Actinium and OpenPlanes. Next tip, check for dataset-specific imports. If you are in the GIS field for some time, you probably heard about the GDAL and how well it can import all different formats or work with all different formats. And GDAL is available to you in GraphJS when you install GraphJS. But it might be sometimes a little more convenient to use some tool which builds on GDAL. So we have several tools for specific formats or specific data sets. These tools are usually in the Addons repository. So if you have a specific data set you are working with or a specific data provider, check it out. There is, for example, iSentinel for working with Sentinel data. And next tip, get support when needed. There are 2 basic types of support. If you don't know what to do next, there are places where you can get help. So one is the community support. Newly we have a Gitter chat room, if you feel chatty. We have also a traditional mailing list. That's probably one of the oldest mailing lists on the internet with archive going back to the date, not necessarily the oldest created. And then we are using the standard options like GIS Stack Exchange and discussions on GitHub. But there is also commercial support. And one of the places where you can get commercial support is the Center for Geospatial Analytics at NC State, where I work. And there are other options too. And the next tip, get things done. So if there is something you feel is not correct in GRASS, maybe it's a bug, maybe you are missing something, maybe you wish there would be something. There are ways how to get that done, how to get that into GRASS.js. For individuals, one thing I would suggest is to organize a community event. It can be a virtual event where you would do the organization, and then different contributors can come and work on a specific task. Depending on what your incentives are, you can lure them into doing something you are interested in. You can also just do it yourself. I think there is many English native speakers in the room, so you can definitely do some fixes in the English grammar inside GRASS.js. But if you speak a different language than English, you can also do translations. And that's actually very easy to set up without any need to know any developer tools. You can also donate money. We have an open collective account. And with money we collected in such a way, in the past we actually created a single window interface through a student grant, as well as some of these visualization tools for Jupyter Notebooks. And the same thing, if you are an organization, there are ways how to get things done. You can donate your employee time. That's a very popular option. And you can also use your money to actually hire specific developer or company to implement whatever feature or fix whatever bug you are interested in. The nice thing about this is that it is this whole model is provider and contractor independent. So let's say you hire NC State to do some feature implementation or bug fixing for you, but then you aren't happy with us. Well, you just go to someone else who is completely independent from us, except that they are working on GRASS.js, and you work with them, and there is no dealing with us anymore. So you can be still happy using GRASS.js even if you don't like us. And what stays the same is that all your previous investments into GRASS.js are still in GRASS.js. So they are in this public pool of software and code which you can keep using. And I got permission from the GRASS Project Steering Committee to give out lifetime licenses for GRASS.js. So I have a couple of them here. They are for all current users and for everyone who asks a question. I was also told that I have to say that the GNU General Public License version 2.0 or higher terms and conditions apply. That means that you can actually use this at home as well as your organization. So for both professional and personal use. And it's actually transferable to another user if you want to give it to someone else. And it also works for all people in your institution. So these are these limitations, but you can work with that, I hope. So see me after the talk to claim one of these. And with that, thank you for your attention, and I will take any questions. Thank you. Questions? Yes.
You mentioned that recently rolling out Docker support for GRASS. Do you have any documentation for that, or are there any, like, the Amazon marketplace that can spin up cluster with that, or is that something?
Yeah, so for that you would have to speak to one of the companies which are providing support to okay, give me the button to spin it up. But we do have the images. They are linked from the website. There's actually a couple of different images you can pick from based on like if you want to like a lightweight image based on Alpine, or you want like more common Ubuntu image. So there are these choices. But for that, at this point, you may want to also look at Actinia. And the expert company for that is Mundialis, who will create it is a REST API for GraphJS. So that's something to explore. Yeah. Yes. Yeah, so that's not web hosting. So you do the hosting, the code will do the generation of the maps for you. So it's a couple lines in Python. It generates an HTML, and you can take that HTML and put that on any web hosting. So it's just a simple HTML website, so it doesn't need any server setup. So that's why I was also saying it's small and middle-sized data. It's not necessarily for real big data applications. Yes.
Are there any plans to extend the LiDAR processing support for graphs platform?
Plans? Yes, I have plans. I am looking for funding for that.
Fair enough.
Yeah.
Thank you.
Yeah.